Okay, we're moving. Today we're going to be talking about scatter plots. This is lesson 1.5 in your. A scatter plot is a graph and it relates two groups of data. A lot of scatter plots in 7th grade, especially when you were doing the book variables and patterns, so you should be pretty good at this. So what we're going to do is we're going to look at this data that's found in the table. And this table is showing data being the hours that students watch TV, and then a test score that they got the next day. And we're going to try to make a scatter plot of that data. So we're going to need our graph, and if you remember back in 7th grade, again, think about what you learned there. We're comparing hours watched in our test score, so we need to just say, those are my two variables, which one might depend on the other, which one's independent and what's dependent. Well, I think the test score that you get might depend on how many hours of TV you watched the night before. So that means the hours watched of TV is my independent variable, and it should go on my x-axis. So I'm going to go ahead and put hours watched of TV. That's going to go down here on x, hours watched. Which means my test score, it depends on that. So I'm going to put it here on the y-axis. Okay, and this is a percent. Okay, second thing I need to do is come up with a good scale here. So I only need to go from 0 to 4 on my hours. My test score, I need to go all the way up to 92. Starts at 65, so you might want to keep that in consideration. I'm probably going to skip some of my hours since I only need to go to 4, so I'm going to just go 1, 2, 3, 4. I would have probably skipped 3, but I know in a later problem I'm going to need some data for 6 hours, so I'll go ahead and include that now. Then I need to come up with something good for my test score. This goes up 14, so I need to try to think of, okay, what's a good scale so I can get all the way up to 92. Well, if I do exactly, I'm counting by 6.57, that would be annoying. So I'm probably going to skip a few and go by about 15 every 2. 15, 30, 45, 60, 75, 90, get up to 105. So that gives me some pretty good space. I can easily get to 92. And then you're just going to simply plot the point. So here's 0 right here for both. 0, 92, I'm just going to put a dot on about where I think that is. 0.5, so halfway in between, 89. 1 is 95, so that was a good one. Whoops, it's probably about here. 2, or another 1 is at 90. 2 is 80. 2.5 is about at 70. And 3 is at 68, so just above that halfway point. And 4 is at 65. Okay. So I've got my dots and then relatively in a good location. And we're going to be coming back to this graph to look at a few things. I should probably give it a title, like, does TV impact tests? Something like that. And you might want to know whether or not you should connect the dots. And right now, this is not continuous data. Something's not continually happening in between the points. So we're going to leave them disconnected for now. Okay. We're going to talk about correlation today. And correlation basically is a way to tell you what type of relationship these two sets of data have with each other. So often, we're going to explore one of these 3 types of correlation. If data is going in a general upward trend, if I looked at the points from left to right like this one, kind of see that they seem to be going up from left to right, we say that there is a positive correlation in between those 2 sets of data. If they seem to be going down from left to right, like in this example, we call that a negative correlation. And in this last problem, they're kind of all over the place. Can't really tell if they're going up or down. They probably don't have any correlation whatsoever, so we say that's no correlation. Okay. Kind of like I just did on that page, sometimes you have a set of data and it's going all over the place, or this one you can see it's going up from left to right a little bit, but it's not very clear, so we might want a trend line, and a trend line is just a way to show correlation more clearly. See this green line in the middle here is a trend line. It gives you the trend of the general data. So when you're making your own trend line, you want to put it kind of in the middle of your points so that about as many points are above it as are below it. And the slope should match pretty closely, so it should go like generally at the same place. Like this, if I was going to do something like here, I might say, well, about half the points are above and about half are below. But obviously it doesn't show the general trend. That's much steeper than my points actually are, so that would be a bad trend line. And something like this, where, it has the right general slope, but, it's not really close to the points, it's all above it, that would also be a bad trend line. You want to get it as close as possible to the middle of your data and matching your slope. Okay, so we're going to go back to that scatter plot that we drew in example 1, and the first task that we need to do is draw a trend line. So I'm going to go back to my data, and I'm going to try to get my line to match as closely as I can and have the right general shape, and about half below and about half above. And to me, I'm just going to extend this all the way to the end of my graph. That's looking like a pretty decent trend line right now. May be able to adjust it to make it a slight bit better, but I think that's a pretty good trend line. So it's going basically in the middle of my points. It's following them as closely as I possibly can get it. Okay, we're going to still go back to that graph, and what I want you to answer is this question. Is there a positive, negative, or no correlation between the hours of TV watched and the test scores? So think to yourself, and I'll go ahead and answer that. But if you look back at this graph, it seems like it's going down from left to right. Every time you watch more TV, in general, the trend is that you're getting a lower test score. This doesn't happen every time. It's not perfect. You can see like the person that got 1 hour watched actually got the best score at 95, but in general they seem to get lower. So we're going to say this has a negative correlation. The graph is going down left to right. As hours watched gets bigger, test scores get lower. That's called a negative correlation. So I'll write negative here. Okay. All right, and then the next question, I want you to use your trend line to approximate the test score of a student who watches 6 hours of TV. So I'm going to go back here to my graph, and that's why I included the 6 earlier. So I just thought, yeah, that would probably be smart because I knew I was going to use it later. And let me just get out this little magic pen right here. So if I go up here from 6 hours of TV, looking about right here where it hits my graph, and I look over, see it looks like, maybe it's about a 35%. Okay, and there's bye-bye magic pen. But it looks like it's not going very well. Okay, they're probably not going to get a very good score. 35% is a good estimate there. Okay, and so then we're going to answer one more question. All right, 35% there. Use your trend line to approximate how many hours of TV a student who scored a 75 watched. So if I go back to my data again and look at this 75, I'm going to get back to that right one. I'm going to find 75 on the y-axis now this time, right here. Look over and drop it right down. Okay, so it looks between 2 and 3, pretty close to 2.5, maybe 2 1/3 or 2 1/4. I'll estimate that they watched about 2 1/3 hours. Your estimate might be a little bit different from mine because we're estimating here. Okay, let's look at a couple critical thinking problems without a graph to see if you get the concept of correlation in general, if they're going to have a positive, negative, or no correlation. And then that will wrap it up for us. So I'm going to give you an example, and I want you to think, would this relationship have a positive correlation, negative correlation, or no correlation? And make sure you're pausing after this, so after each example, so you don't just steal my idea. So the first one, A, a person's height and their shoe size. So think about, would that have a positive, negative, or no correlation? When you're first making this, you might want to think of or visualize a graph in your head. So if I was thinking about something like this, a person's height, as the height's getting bigger, most of the time a shoe size is going up too. So like a short height might be a small shoe size. It's not going to happen perfectly, but I think in general we'd see that this graph is going up from left to right. This would have a positive correlation. Okay. Second one, the temperature, so the outdoor temperature, and the number of people who go snow skiing. Think about what might happen here. Okay, I might think again, I might try to visualize a graph until I'm getting really good at this. As the temperature gets hotter and hotter, snow melts a lot. So, when it's cold and you have snow, you probably have more people skiing up here. And as it gets hotter and hotter, there'd probably be fewer and fewer people skiing because they'd have to go to Alaska or something like that to be able to ski. This is probably going to have a negative correlation. Okay, I guess I cut off a little bit of this video, but let me see if I can scooch it up a little bit. Nope. Okay, well here's what it says. Your free throw shooting percentage and the number of pets you have. So your free throw shooting percentage and the number of pets. I'll write that in here because you probably can't see it. Okay, so think about that one. Okay, now what I'm thinking is probably my ability to play basketball and shoot a free throw really has nothing to do with how many pets I have in my household. So probably some people that have lots of pets might have a really high free throw percentage and some might have a really low one, and vice versa. This has really no correlation whatsoever. It's not going to impact each other. It's no relationship even, much less no correlation. Okay, so I hope you can see the difference between the types of correlation, and I refreshed your memory a little bit on how to make a scatter plot. And I'll see you soon in class. Have a great day.